This video is for educational purposes only and is not intended as medical advice. Please consult a qualified healthcare professional before making any health-related decision.
What if one of the most important signals about your health was quietly flowing through your veins every moment, invisible, silent, yet powerful enough to shape your energy, your brain, and even the way your body ages? Blood sugar is one of those signals. It is easy to overlook because we cannot feel it rising or falling in real time. Yet inside the bloodstream, glucose is constantly moving, fueling billions of cells that depend on it for survival. For seniors especially, understanding blood sugar is not simply about preventing disease. It is about understanding how the body manages energy, balance, and resilience as the years pass. Glucose is the most basic form of fuel the human body uses. Every time we eat, carbohydrates are broken down into glucose molecules that enter the bloodstream. From there, a remarkable biological process begins. The pancreas releases a hormone called insulin, which acts almost like a key. This key unlocks the doors of our cells, allowing glucose to move inside where it can be used for energy. Without this process, even if sugar is present in the blood, the cells cannot access it efficiently. This system works beautifully in a healthy body. Blood sugar rises slightly after eating, insulin responds, and cells absorb the glucose they need. After some time, levels gently return to normal. It is a dynamic rhythm, happening day after day without conscious effort. But as people grow older, this rhythm can begin to change. The body may not respond to insulin as efficiently as it once did, a condition scientists call insulin resistance. In this situation, the cells become less responsive to insulin's signal, which means glucose begins to remain in the bloodstream longer than it should. At first, these changes are extremely subtle. A person may feel completely normal. There may be no discomfort, no clear symptoms, nothing that signals something is wrong. Yet a routine health report may quietly reveal that fasting glucose levels are slightly higher than expected. That small shift in numbers is not just a statistic. It is a message from the body indicating that its energy management system may be under strain. The fascinating part is how the body tries to compensate. When cells resist insulin, the pancreas often responds by producing even more insulin in an attempt to push glucose into the cells. For a while, this strategy works. Blood sugar may stay within an acceptable range because the body is working harder behind the scenes. But this increased effort cannot continue forever. Over time, the pancreas may struggle to keep up with the demand, and blood glucose levels gradually begin to rise. This slow progression is why monitoring fasting blood sugar in health reports becomes so important for seniors. Fasting glucose provides a snapshot of how the body manages sugar after several hours without food. It reflects the balance between insulin production and the cell's ability to respond to that insulin. When the number begins to creep upward, it suggests that the delicate partnership between these systems may be shifting. Another valuable measurement sometimes included in reports is the HA1C test. Unlike a single blood sugar reading, this test reflects the average glucose level over the past 2 to 3 months. It works because glucose molecules attach themselves to hemoglobin in red blood cells. Since these cells circulate for about 3 months before being replaced, scientists can estimate long-term blood sugar patterns by examining how much glucose has attached to them. This concept reveals something profound about the body. Blood sugar is not just a momentary event, it is a pattern that unfolds over time. Each meal, each period of rest, each walk, and each night of sleep contributes to that pattern. When seniors observe their HbA1c levels, they are essentially observing the story of their metabolism over several months of life. But blood sugar is not merely about numbers on a report. Its influence reaches nearly every system in the body. The brain, for instance, depends heavily on glucose as its primary source of energy. When levels fluctuate too dramatically, mental clarity and concentration can be affected. Stable glucose levels support steady cognitive function, something especially valuable in later years when maintaining mental sharpness becomes a priority. The circulatory system is also deeply connected to blood sugar balance. When glucose remains elevated for long periods, it can gradually affect the delicate inner lining of blood vessels. Scientists have observed that high sugar levels lead to inflammation and oxidative stress within these vessels. Over time, this environment may encourage the development of vascular complications. Even the smallest structures in the body can be influenced by prolonged glucose imbalance. Tiny blood vessels that nourish the eyes, kidneys, and nerves are particularly sensitive. When seniors monitor their blood sugar early and consistently, they are essentially protecting these microscopic pathways that quietly support vision, filtration, and sensation. What makes this topic truly empowering is that blood plee responsive to lifestyle choices. Movement, nutrition, sleep, and stress management all influence how the body handles glucose. A simple daily walk can help muscles use glucose more efficiently. Balanced meals containing fiber, protein, and healthy fats slow the absorption of sugar into the bloodstream. Adequate sleep supports hormonal balance, which in turn affects insulin sensitivity. These everyday habits interact with biology in remarkable ways. The muscles become active participants in glucose regulation, absorbing sugar for energy during physical activity. The digestive system processes food more gradually when meals are balanced. Hormones align more smoothly when the body is rested and calm. Over time, these small daily choices create measurable changes in health reports. Blood sugar readings may stabilize, insulin sensitivity may improve, and the body's natural rhythm of energy regulation can regain its harmony. For seniors, this understanding transforms a simple laboratory value into something far more meaningful. Instead of seeing blood sugar as a distant medical concern, it becomes a living indicator of how the body is responding to life itself. Each measurement reflects the ongoing conversation between cells, hormones, organs, and habits. And when that conversation is understood with curiosity rather than fear, the numbers in a health report begin to reveal something far more valuable than data. They reveal the remarkable adaptability of the human body and its lifelong effort to maintain balance within an ever-changing world of energy, nourishment, and time. There is a quiet paradox hidden within the word cholesterol. For many people, especially seniors reading their health reports, the word immediately creates concern. Yet inside the human body, cholesterol is not an enemy. In fact, it is one of the most essential building materials of life. Every cell membrane in the body depends on cholesterol to maintain its structure and flexibility. Certain hormones cannot exist without it. Even vitamin D, which helps regulate bone strength and immune function, begins its biological journey from cholesterol. The real story, therefore, is not about eliminating cholesterol, but about understanding how it moves through the body and how balance determines whether it supports health or gradually strains the cardiovascular system. To understand this balance, it helps to imagine the bloodstream as a vast transportation network. Cholesterol itself cannot travel freely through blood because it does not dissolve in water. Instead, the body packages it into microscopic particles called lipoproteins. These particles act like transport vehicles, carrying cholesterol to different parts of the body where it is needed. When seniors look at their health reports and see terms such as HDL and triglycerides, they are essentially looking at different types of these transport systems and how they are functioning. One of the most discussed markers is LDL cholesterol, often called low-density lipoprotein. LDL particles carry cholesterol from the liver to tissues that require it for cellular repair and hormone production. In reasonable amounts, this process is completely natural and necessary. The body constantly renews cells, and cholesterol is part of the raw material required for this renewal. But when LDL particles become too abundant in the bloodstream, a different process can begin to unfold within the arteries. Arteries are not simply hollow tubes carrying blood. They are living tissues lined with delicate cells that respond to chemical signals and mechanical pressure. When LDL cholesterol levels remain elevated over long periods, some of these particles may begin to accumulate within the walls of arteries. The body recognizes this accumulation and sends immune cells to manage the situation. These cells attempt to absorb and break down the cholesterol deposits, but over many years this process can lead to the formation of fatty plaques along the arterial walls. What makes this process particularly fascinating is its gradual nature. It does not happen overnight, nor does it usually produce immediate symptoms. Decades can pass while these changes develop quietly. Blood continues to flow, the heart continues to pump, and daily life proceeds as normal. Yet within the arterial walls, the balance between cholesterol transport, immune activity, and inflammation may slowly shift. This is why monitoring cholesterol levels in health reports becomes so valuable, especially in later stages of life when the cumulative effects of metabolism and lifestyle begin to appear more clearly. In contrast to LDL, another type of particle known as HDL or high-density protein plays a protective role. HDL acts almost like a cleanup system within the bloodstream. These particles collect excess cholesterol from tissues and arterial walls and transport it back to the liver, where it can be processed or removed from the body. Because of this function, HDL is often referred to as beneficial cholesterol. Higher HDL levels suggest that the body has a stronger ability to maintain balance in cholesterol circulation. The relationship between LDL and HDL is not simply a competition between good and bad elements. Instead, it is more like a dynamic equilibrium. LDL delivers cholesterol where it may be needed, while HDL helps remove excess and maintain stability. When this balance is healthy, the circulatory system functions smoothly, allowing blood to move freely through arteries that remain flexible and resilient. Triglycerides represent another important component, often listed in health reports. While cholesterol is used mainly for structural and hormonal purposes, triglycerides serve as a form of stored energy. After a meal, when the body receives more calories than it immediately requires, some of that energy is converted into triglycerides and stored in fat cells. Later, when the body needs additional fuel, these triglycerides can be broken down and released into the bloodstream. In moderate amounts, triglycerides are a normal and useful part of metabolism. However, when triglyceride levels become consistently elevated, they can indicate that the body is receiving more energy than it can effectively use or process. High triglycerides are often linked with insulin resistance, metabolic imbalance, and increased cardiovascular risk. When seniors review this value in their reports, it offers insight into how the body is managing energy intake and storage over time. What makes cholesterol and lipid markers particularly interesting from a scientific perspective is how strongly they reflect lifestyle patterns accumulated across many years. Nutrition plays a major role, especially the types of fats and carbohydrates consumed regularly. Diets rich in processed foods, refined sugars, and certain unhealthy fats can gradually shift lipid levels in unfavorable directions. On the other hand, diets containing fiber, plant-based nutrients, healthy fats from sources like nuts and fish, and balanced portions can support healthier lipid profiles. Physical activity also interacts deeply with cholesterol metabolism. When muscles are active, they use circulating fats and glucose for energy. Regular movement encourages the body to process triglycerides more efficiently and can help raise HDL levels. Even moderate exercise, such as daily walking, can influence these biological systems in meaningful ways over time. Age itself also plays a role. As people grow older, metabolic processes may slow slightly, and the liver's handling of cholesterol may change. Hormonal shifts can also influence lipid patterns. This is why health professionals often recommend that seniors monitor their lipid profiles regularly. These numbers provide early insight into how the cardiovascular system may be evolving. Perhaps the most remarkable aspect of cholesterol biology is that it represents both vulnerability and adaptability. While high LDL and triglyceride levels can contribute to arterial changes over time, the body also retains a strong capacity to restore balance when supportive habits are introduced. Improvements in diet, physical activity, weight management, and sleep quality can gradually influence lipid metabolism and lead to measurable changes in health reports. For seniors reviewing their cholesterol levels, this knowledge transforms the experience of reading those numbers. Instead of seeing them as static judgments about health, they become indicators of an ongoing biological dialogue between the body and daily life. Each value reflects countless molecular interactions taking the bloodstream, liver, and tissues. And within that complex system lies the possibility of adjustment, improvement, and renewed balance as the body continues to maintain harmony within the flowing currents of blood, energy, and cellular renewal. Hidden deep within the body, working quietly every second of every day, are two organs that rarely ask for attention, yet perform one of the most sophisticated tasks in human biology. The kidneys are often overlooked because their work happens silently, without dramatic signals or sensations. Yet every moment, these organs are filtering the blood, maintaining chemical balance, regulating fluids, and protecting the body from the gradual buildup of waste. When seniors receive their health reports and see markers related to kidney function, they are looking at the performance of a biological filtration system that has been operating continuously for decades. To truly appreciate the kidneys, it helps to imagine the immense scale of their work. Although each kidney is roughly the size of a small fist, together they filter an astonishing volume of blood each day. Nearly all the blood circulating through the body passes through these organs repeatedly. Within the kidneys are millions of microscopic filtering units called nephrons. Each nephron acts like a tiny purification station, carefully separating substances that the body needs from those that must be removed. Blood enters these filtering units under gentle pressure. Water, salts, and small molecules pass through delicate membranes, while larger components, such as blood cells and essential proteins, remain within the bloodstream. From this process emerges a filtered fluid that will eventually become urine. But before that happens, the kidneys perform an additional remarkable task. They reabsorb many of the substances the body still requires, such as glucose, certain minerals, and a significant portion of the filtered water. This selective reabsorption ensures that valuable resources are not lost unnecessarily. In this way, the kidneys function not merely as waste disposal organs, but as regulators of the body's internal environment. They constantly adjust the concentration of electrolytes like sodium and potassium, helping maintain stable nerve function and muscle activity. They also play a role in regulating blood pressure by controlling fluid levels and releasing hormones that influence the constriction or relaxation of blood vessels. Because these processes occur so quietly, early changes in kidney function often go unnoticed without laboratory testing. This is why certain markers in health reports become especially valuable for seniors. Among the most commonly measured indicators is creatinine, a substance produced during normal muscle metabolism. As muscles use energy, small amounts of creatinine enter the bloodstream. Under healthy conditions, the kidneys remove it efficiently through filtration. When kidney function begins to slow, creatinine may accumulate slightly in the blood. Even a small increase can signal that the filtration process is not operating as effectively as before. For doctors and scientists, creatinine levels provide an important clue about how well the kidneys are performing their essential task. Another important measurement derived from creatinine is the estimated glomerular filtration rate, often abbreviated as eGFR. This value represents an estimate of how much blood the kidneys are filtering each minute. It is calculated using creatinine levels along with factors such as age and sometimes body characteristics. The number offers a broader perspective on kidney efficiency, helping clinicians understand whether filtration is within a healthy range. For seniors, observing this value can be particularly insightful because kidney function naturally evolves over time. The filtering capacity of the kidneys may gradually decline with age. Much like other organs experience subtle changes after decades of continuous work. This gradual shift does not necessarily mean disease is present, but it does highlight the importance of monitoring the trend over time. What makes the kidneys especially fascinating is their resilience. Despite filtering such large volumes of blood every day, they often maintain stable function for many years even under challenging conditions. However, certain factors can place additional stress on these organs. High blood pressure, for example, increases the pressure within delicate kidney blood vessels, which over long periods may affect their structure. Similarly, prolonged high blood sugar can influence the tiny filtering membranes, gradually altering their efficiency. Hydration also plays an important role in kidney health. Water is the medium through which filtration occurs, and maintaining adequate fluid intake supports the kidney's ability to flush waste products effectively. When the body becomes chronically dehydrated, filtration can become more concentrated, potentially placing additional strain on the system. Another intriguing aspect of kidney function is the way these organs communicate with the rest of the body. The kidneys release a hormone called erythropoietin, which signals the bone marrow to produce red blood cells. This connection links kidney health directly to oxygen transport within the bloodstream. When kidney function declines significantly, this hormonal signal may weaken, which can influence red blood cell production. The kidneys also help activate vitamin D, a process essential for maintaining calcium balance and bone health. In this sense, the kidneys quietly influence not only blood chemistry, but also the strength of the skeletal system. It is remarkable to realize that two small organs in the lower back contribute to such a wide range of physiological processes. From a scientific perspective, kidney markers in health reports provide a glimpse into the body's ability to maintain internal stability. The human body thrives when its internal environment remains balanced, a concept scientists call homeostasis. The kidneys are central to this balance, constantly adjusting fluid levels, mineral concentrations, and waste removal to keep the bloodstream within safe limits. For seniors reviewing their health reports, creatinine levels and filtration estimates are not merely technical measurements. They represent the ongoing performance of an intricate biological purification system that has been quietly supporting life for decades. Each value reflects millions of microscopic filtering events taking place every minute. What makes this knowledge empowering is that kidney health is influenced by everyday habits. Maintaining healthy blood pressure, managing blood sugar, staying physically active, and drinking adequate fluids all support the long-term function of these organs. Even moderate improvements in lifestyle can reduce stress on the kidneys and help preserve their efficiency. In the end, kidney function markers reveal something profound about the body's inner world. They show how continuously the body works to maintain purity and balance within the bloodstream. And when seniors learn to read these values with curiosity and awareness, the numbers on a laboratory report begin to tell a deeper story about filtration, regulation, and the quiet persistence of organs that have been faithfully protecting the body's internal environment through decades of life, change, nourishment, and time. Imagine for a moment that within every drop flowing through the body, there exists an entire community of living cells, each with a specific role, each responding to signals, threats, and needs. This invisible community works tirelessly, traveling through arteries and veins, carrying oxygen, defending against microscopic invaders, and repairing damage whenever it appears. When seniors look at a health report and see something called a complete blood count, they are essentially looking at a snapshot of this living community. It is one of the most revealing windows into the body's internal activity, because it shows how the fundamental cellular workers of the bloodstream are performing their responsibilities. The bloodstream is often thought of simply as a liquid pathway, but in reality it is more like a dynamic transportation system filled with specialized units. Red blood cells are among the most numerous members of this system. Their primary responsibility is to transport oxygen from the lungs to every tissue in the body. Oxygen is essential for cellular respiration, the process through which cells produce energy. Without a steady supply of oxygen, even the most basic biological activities would slow or stop. What makes red blood cells remarkable is their structure. They are shaped like tiny flexible discs, designed specifically to travel through extremely narrow blood vessels called capillaries. These vessels are so small that red blood cells must sometimes bend and twist to pass through them. This flexibility allows oxygen to reach areas of the body that would otherwise be inaccessible. Hemoglobin, the protein inside red blood cells, binds to oxygen molecules in the lungs and releases them when the cells reach tissues that require energy. A complete blood count measures several aspects of these cells, including how many are present and how much hemoglobin they contain. When red blood cell levels fall below normal ranges, the body may struggle to deliver oxygen efficiently. This condition, commonly known as anemia, can lead to fatigue, weakness, or reduced physical endurance. For seniors, monitoring red blood cell counts helps reveal whether the body's oxygen delivery system is functioning at its best. White blood cells represent another crucial part of the blood's cellular community. While red cells focus on oxygen transport, white cells are responsible for protection. The human body is constantly exposed to bacteria, viruses, and other microscopic organisms in the environment. Most of the time, we remain unaware of these encounters because the immune system is quietly managing them. White blood cells act as the body's surveillance and defense units. Different types of white cells perform different tasks. Some patrol the bloodstream looking for signs of infection. Others communicate with immune tissues to coordinate responses when a threat is detected. Certain cells are capable of engulfing and digesting invading microbes, while others produce antibodies that help identify and neutralize pathogens. The complete blood count measures the total number of white blood cells circulating in the blood. When this number increases significantly, it can indicate that the immune system is responding to infection, inflammation, or another form of stress within the body. Conversely, when the number is unusually low, it may suggest that the immune system's ability to respond to challenges has weakened. For seniors, these values can provide valuable insight into how effectively the immune system continues to function with age. The immune response often changes gradually over time, and a simple blood test can offer early clues about how the body is managing internal and external stressors. Another essential component measured in a complete blood count is platelets. Unlike red and white blood cells, platelets are not full cells but tiny fragments produced by bone marrow. Despite their small size, they perform one of the most critical functions in survival, controlling bleeding and repairing damaged blood vessels. Whenever a blood vessel is injured, even in a minor way, platelets rapidly gather at the site of the damage. They stick to the vessel wall and to one another, forming a temporary plug that slows or stops the flow of blood. At the same time, they release chemical signals that activate a complex series of clotting reactions. These reactions strengthen the platelet plug and help form a stable clot that protects the body from excessive blood loss. The platelet count in a health report shows how many of these clot-forming fragments are circulating in the bloodstream. If platelet levels drop too low, the body may struggle to stop bleeding efficiently. If they become too high, there may be an increased tendency for unwanted clot formation. Maintaining balance is essential because both extremes can affect circulation and overall health. Beyond simply counting cells, modern blood reports also examine the size and characteristics of these cellular components. For example, measurements of red blood cell size can help reveal whether the body is receiving adequate nutrients such as iron, vitamin B12, and folate. These nutrients are vital for healthy blood cell production, and deficiencies can subtly influence the structure and function of red cells. This deeper layer of information transforms the complete blood count from a simple test into a comprehensive biological report. It reflects how the bone marrow is producing blood cells, how the immune system is responding to challenges, and how effectively oxygen is being delivered throughout the body. What makes this test particularly valuable for seniors is that it often reveals patterns before noticeable symptoms appear. The body is constantly adapting to internal conditions such as nutrition, hydration, inflammation, and stress. Changes in blood cell counts can provide early indications that one of these systems may need attention. For example, a slight drop in hemoglobin may encourage doctors to investigate nutritional intake or hidden sources of blood loss. An unexpected rise in white blood cells may lead to closer observation of possible infections or inflammatory conditions. A shift in platelet levels might prompt further evaluation of clotting or bone marrow activity. In this way, the complete blood count becomes a kind of biological conversation between the body and medical observation. The numbers themselves are not the story. They are clues that help reveal what the cellular workforce of the bloodstream is experiencing. Perhaps the most fascinating aspect of this test is the realization that billions of cells are continuously being produced, used, and replaced within the body. The bone marrow generates new blood cells every day to maintain this delicate balance. Red blood cells circulate for about 4 months before being replaced. Platelets live only about a week before new ones take their place. White blood cells constantly adapt to the immune challenges the body encounters. For seniors reviewing their health reports, this perspective changes the way a complete blood count is understood. Instead of appearing as a technical list of numbers, it becomes a living portrait of the body's internal workforce. It reveals how oxygen travels, how immunity stands guard, and how the body prepares itself to repair damage whenever it occurs. Within those measurements lies a quiet reminder that the bloodstream is not simply a fluid pathway, but a vibrant system of cellular cooperation, where countless microscopic participants move together in an intricate choreography designed to sustain life, defend health, and support the body's remarkable capacity for resilience across the unfolding years of human experience. With every beat of the heart, A silent wave travels through the arteries of the body. It moves quickly, almost imperceptibly, carrying life, sustaining blood to every organ, every muscle, every tiny cell that depends on oxygen and nutrients. Most of the time, we never notice this extraordinary process. The heart beats thousands of times each day without asking for attention. Yet hidden within this rhythm is a powerful measurement that reveals how smoothly the circulatory system is functioning. Blood pressure, often written as two simple numbers on a health report, represents the force with which blood moves through the arteries and the resistance it encounters along the way. At first glance, these numbers may seem routine, almost ordinary. Many seniors have seen them measured countless times during doctor visits or routine checkups. But behind those numbers lies a complex conversation between the heart, the blood vessels, the kidneys, and even the nervous system. Blood pressure is not merely a statistic. It is a reflection of how the entire circulatory network responds to the demands of life. The first number in a blood pressure reading is known as systolic pressure. It represents the force generated when the heart contracts and pushes blood into the arteries. In that brief moment, the heart's muscular walls tighten, sending a surge of blood outward through the aorta and into the branching network of vessels that reach every corner of the body. This surge must be strong enough to deliver oxygen to distant tissues, yet balanced enough to avoid placing excessive strain on the arterial walls. The second number is called diastolic pressure. It measures the pressure in the arteries when the heart relaxes between beats. During this phase, the heart refills with blood while the arteries maintain enough pressure to keep circulation moving smoothly. This resting pressure reveals how well the blood vessels are able to maintain steady flow even when the heart is momentarily at ease. Together, these two numbers create a picture of how efficiently the cardiovascular system is working. The heart provides the driving force, while the arteries act as flexible pathways that expand and contract with each pulse of blood. When this interaction remains balanced, blood flows effortlessly, delivering oxygen and nutrients to tissues while removing metabolic waste. What makes blood pressure particularly interesting as a scientific perspective is how many factors influence it. The elasticity of the arteries plays a central role. In younger individuals, arterial walls are often highly flexible, allowing them to expand easily when blood is pumped through them. This flexibility helps absorb the pressure generated by each heartbeat, keeping blood pressure within a comfortable range. As the body ages, however, these vessels can gradually become less elastic. Years of exposure to circulation, metabolic processes, and environmental influences can change the structure of the arterial walls. They may become slightly stiffer, which means they do not expand as easily when blood flows through them. When this happens, the heart must generate greater pressure to move blood through the same pathways. For seniors, this gradual shift in arterial elasticity is one reason blood pressure monitoring becomes especially important. Even small increases in pressure can reflect changes in how the circulatory system is adapting to age and lifestyle. Health reports that include consistent blood pressure readings allow doctors and patients to observe patterns over time rather than focusing on a single momentary measurement. Another fascinating aspect of blood pressure relation involves the kidneys. These organs play a significant role in controlling fluid balance within the body. By adjusting how much sodium and water are retained or excreted, the kidneys influence the total volume of blood circulating through the vessels. When fluid levels rise, blood volume increases, which can raise pressure within the arteries. When fluid levels decrease, pressure may fall. The nervous system also participates in this delicate balance. Specialized sensors located in blood vessels constantly monitor pressure levels and send signals to the brain. If pressure drops too low, the nervous system can signal the heart to beat faster or the blood vessels to constrict slightly. If pressure rises too high, the system can encourage relaxation of the vessel walls. These adjustments occur automatically, often within seconds, maintaining stability even when a person stands up quickly, exercises, or experiences emotional stress. Because so many systems contribute to blood pressure regulation, the values recorded in a health report represent more than just heart function. They reflect the combined activity of vascular structure, kidney function, hormonal signals, and neural control. This interconnectedness explains why sustained high blood pressure can gradually influence several parts of the body. Over many years, consistently elevated pressure may place strain on the heart itself. The heart muscle may thicken slightly as it works harder to pump blood against increased resistance. At the same time, delicate blood vessels in organs such as the brain, kidneys, and eyes may experience subtle structural changes. These changes usually develop slowly, which is why high blood pressure is often called a silent condition. The remarkable thing, however, is how responsive blood pressure can be to lifestyle choices. Physical activity strengthens the heart and improves the flexibility of blood vessels. Balanced nutrition, particularly diets rich in fruits, vegetables, and minerals like potassium, supports vascular health. Reducing excessive salt intake can help maintain appropriate fluid balance within the circulatory system. Stress management also plays a role. Emotional stress triggers the release of hormones that temporarily raise blood pressure as part of the body's natural alert system. While this response is useful in short bursts, chronic stress may keep the system activated longer than necessary. Practices that encourage relaxation, such as steady breathing or mindful movement, can help restore equilibrium. Sleep is another important factor. During restful sleep, the body shifts into a restorative mode where heart rate and blood pressure naturally decrease. This nightly period of reduced pressure allows the cardiovascular system to recover from the demands of the day. When seniors observe blood pressure readings in their health reports, they are essentially looking at a summary of how these many influences are interacting. Each value captures a moment in the ongoing dialogue between the heart's strength, the arteries' flexibility, the kidneys' regulation of fluids, and the nervous system's careful adjustments. Over time, these readings create a pattern that reveals whether the circulatory system is operating smoothly or facing increasing resistance. By paying attention to this pattern, seniors gain insight into how their bodies are responding to daily habits, environmental conditions, and the natural passage of time. Within those two numbers lies the story of the heart's effort to sustain life through constant motion, the artery's ability to adapt to pressure and flow, and the body's remarkable capacity to regulate itself through countless invisible adjustments that continue with every heartbeat, every breath, and every quiet moment when blood travels through the vast network of vessels that sustain the living rhythm of the human body.